Thank you for doing that. Being a Delaware native, Brittany graduated from Delaware State University with her BS in natural resources. She later received her MS in wildlife fisheries, aquacultural at Mississippi State University, working on commercial scale low salinity cultural techniques for Gulf Kelly fish. I think I pronounced it right. Currently in a role at TAMU, she provides technical expertise on aquatic vegetation management to the general public through identifying specific plant species, recommending correct management practices, and delivering presentations along with servicing as a lab specialist for TAMU Aquatics Diagnostic Laboratory. She has recently started working towards her doctorate at Texas A&M University. And with that being said, I'll have her take the presentation. Okay, Brittany, you ready?
Awesome. Thank you. Yep. Can you see my slides okay?
Yes.
Awesome. Thank you for the introduction. I've already seen some familiar faces.
Hey, Brittany, before you continue, can you increase the volume some more? You're coming across, but not that loud.
Okay. Let me see. Okay, I might just have to stay really close to my computer. Is this better?
Yes. Mm-hmm.
Okay. So thank you again for the introduction. Sorry about the sound there for a second, but like I was going to say, I've already seen some familiar faces on Zoom and in the room there from the TMN meeting this past weekend. So really glad you guys are already getting back into your routine the very next day. So we're going to go ahead and get started. And I picked this topic just because it's something that I've been looking into a little bit more, especially since starting my PhD here. I'm actually taking some biological control classes in the entomology department. And so this is something that's helped me out in terms of understanding a wide variety of options for aquatic vegetation management, right? And so if you attended my beneficial plants talk, I went over how when I go out to private landowners' properties, the first thing I ask them is, what are you trying to manage? What's your overall goal? Because before you decide on any type of management option, you need to understand the reasons that you're managing, right? And there's two different categories that I put management into, and we'll talk about that in a second. But the real question is, do I need to manage this? Of course, if you manage one thing, something worse may actually come in and fill that niche. And so it's important to understand or to identify the target and non-target species when I go out and work with private landowners. If you're assessing property or a pond through one of your projects, you'll be assessing and figuring out which are your target and your non-target species. What do you want there and what don't you want there? Also, your level of concern. Obviously, if it's an invasive species, your level of concern is going to be a lot more than maybe if it's a native, just nuisance species. And then, of course, it's going to be dependent on water use. We have many different inland properties, impoundments, whatever you want to call them, across the state that either use livestock, they use water for a fishery, they use water for recreational uses, or maybe it's a multi-use impoundment as well. And so these are all things to think about before we get into any type of control options. And then you want to weigh the costs and benefits of management, cost of equipment, cost of labor. In this case, we're talking about introducing organisms for biological control, and that also comes at a cost. And so when I'm talking about what does management entail, again, if you would have attended my talk on Saturday, I went into restoration, a little bit about beneficial aquatic plants that you can place around your pond and the different services that they do to that ecosystem. Well, we're going to focus more on control. This is primarily what I deal with, but I'm trying to also dabble in the restoration world because, of course, after you get something controlled, or if you knock back or you're able to reduce an invasive species, most of the time that is a disturbed area that you need to go in and do some type of restoration with as well. But we're going to focus on control. So when we talk about control in just the broad sense, this is the method to eradicate or limit the overall growth. And so this is to exercise restraining or directing any influence over. And so we typically break these up into really broad categories. We have our physical and cultural control, mechanical control, biological control, and chemical control. So just to kind of touch on each of these quickly before we dive into biological control, there's no silver bullet for aquatic vegetation. Most of the time, we're using multiple methods in our toolbox. So multiple different types of control, maybe either within a certain type or between types as well. And so we call this integrated pest management. And so it's just the combination of various control methods to manage pest populations. And again, this is what we also refer to as our toolbox. This is where we draw our management strategies from. And it really just depends on the overall situation or specific site that we're managing, whether or not one or more of these options are feasible. And so using IPM, as you've probably heard, this is has the overall aim to provide the best control while considering both economic and environmental sustainability. So for our first one, physical and cultural control, this is just altering the environment or the attitudes rather than direct control. And so cultural control focuses more on education and preventing introductions. So think of that like your campaigns that you see outside of Lake Conroe on rinse, drain, dry. So any boat ramp monitoring and wash stations to help prevent the spread, to get the public to start thinking about preventing introductions, right? Because that's one of the biggest way to be preventative in having aquatic vegetation is to prevent introductions overall. Whereas more on the physical side, this is going to focus on non-chemical, non-motorized control techniques. And so you can see here, this is just this small net, and somebody is netting out watermill, which is a very small aquatic plant. Mechanical control, this is direct control using large power-driven equipment. And so just an example of this are shredder and cutter boats. And this is what was used early on in aquatic vegetation management when water hyacinth and alligator weed first started establishing in the southern U.S. The U.S. Army Corps of Engineers, that's what they actually used to help eradicate the issue, or what they thought would help eradicate the issue. What some of the problems with shredder and cutter boats are, though, many of our aquatic vegetation species create fragments, and they reproduce very readily from fragments. And so if you're going in with a shredder or a cutter boat, you're probably producing a lot of fragments, right? And so if you're not taking them all out of the water column, it can actually make the issue worse. But we typically use this, if we do, for floating and emergent vegetation. So this is vegetation that's floating at the water surface, not connected to the bottom. And then our emergent vegetation is really just shoreline vegetation. Chemical control, this is where we're using pesticides to control nuisance species. So this includes our herbicides and algicides. And so in order to use chemical control for aquatic vegetation, they must be labeled for aquatic use to use in or around water. Typically, they're used at extremely low doses in the water, and they do not persist very long in water. So usually only a few days is their half-life. I put this at the bottom. They do not bioaccumulate in the fatty tissues of humans or animals. This is with aquatic use herbicides. And so that's why I always include this, because it's very important that If you ever give any type of recommendation, or if you're talking to your buddy about how he can control something in his pond, and if he's going to use chemical control, make sure that they're looking for that aquatic use label. It's very important. A lot of terrestrial herbicides have the same active ingredient in it, but there's other ingredients that can actually harm aquatic organisms. So we're not going to talk about chemicals today. We're going to talk about one of the methods in the toolbox, and that's biological control. And that's using one organism to control another. So typically with aquatic vegetation, if you've done any reading on it, if you've seen any blogs from Texas Parks and Wildlife or some other agencies, you're going to usually think of insects and herbivorous fish. And so we have two different schools of thought for biological control. We have classical biocontrol. And so this is introducing natural enemies from their native range to control non-native invasive species. And so this is reuniting invasive species with their already co-evolved natural enemies, right? So we'll go over some examples of this in a minute, but obviously if giant Salvinia is from Brazil, they're going to be going to look in Brazil for some of these natural enemies to help determine which may be the best to control it. And that's exactly how they start up a lot of these biological control programs, right? They go searching in the native area of the pest. And so typically this is very selective. These species most of the time usually will only consume one species, and then very rarely they'll consume a few others. So these do offer very long-term control for the most part, because remember, in their native range, they're able to live together. For the most part, these natural enemies won't completely eradicate the issue, but it'll keep it to a lower level where it's not as much of a pest. The issue with classical biocontrol, or something to keep in mind when they're trying to identify some of these natural enemies, is that once it's released, it cannot be recalled. It is self-sustaining, especially if it has that pest there, usually in large amounts. That's why they're being released. It's going to be very hard to try to take them out of the environment, right? So with our classical biocontrol, that's when we normally think of our insects, and we'll go over some examples of that in a second. But the other school of thought is non-classical biocontrol, or augmented biocontrol. And so this is introducing natural enemies when man manipulates the natural enemy populations for the purpose of the population control. And so this is going to be the release of natural enemies that are reared in focused facilities. And so for the most part, this is going to be our herbivorous fish. So our tilapia and our grass carp, which we'll talk about in a little bit. Typically, this offers temporary suppression because usually they're not self-sustaining. And you'll see that with our herbivorous fish like tilapia and grass carp, after maybe a year, you need to restock. And then with our grass carp, maybe after 5 to 7 years, you may need to restock. And we'll talk about why in a second, but they're not self-sustaining, where some of these insects that are a part of classical biocontrol can be self-sustaining, especially if the climate conditions are right. So going over some examples. So we have the alligator weed flea beetle, which was originally introduced in 1964 to take care of the alligator weed issue. It was mostly effective on floating mats that have been formed. So if you know anything about alligator weed, it's a shoreline plant. And you can see it at the upper right here growing on the outside of a pond. But on the bottom left, you can actually see where it's starting to send out its runners, and it's actually growing across the pond. So these mats become very thick, very entangled, and there's two different types of management depending on where it is in the water column, which is kind of interesting about alligator weed, and probably why it's so invasive, because it's able to adapt so readily. This alligator weed flea beetle is not very cold tolerant, so it typically dies during freezing conditions, which can be an issue, especially as we've seen alligator weed is starting to move further north. So there's a lot of research being put into this area in some of our other states, like in northern Mississippi. So our agencies will go out periodically, and they'll collect and they'll release. On the other hand, the alligator weed thrips were also introduced in 1964, and they're more effective on those terrestrial mats, so those shoreline mats that you see in the upper right-hand corner. And the thrip is at the bottom right, and the flea beetle is at the top left. Giant Salvinia weevil, this is something that you've all probably heard of. This was introduced in 1960 for both common Salvinia and in 2001 for giant Salvinia. So the adults feed on the leaf buds and the leaves, and the eggs are deposited on the underside of the leaves or root systems. And so this allows the larvae to tunnel inside of the plant, and the plants eventually turn brown and lose buoyancy, which as you can see here, with giant Salvinia, a lot of times our agencies like Texas Parks and Wildlife put up these booms, these floating booms in some of our large reservoirs, and they'll actually go in, and not only do the booms stop the spread of giant Salvinia into other areas, but they'll go in and they'll release these giant Salvinia weevils on top of these host plants, as you can see what she's doing there. And they almost create these nurseries in these floating booms. So they have them contained in an area, but the weevils are able to do what they do best and move on to populations that don't have the weevils currently present or aren't currently affected by them. And that's how they're able to kind of integrate. That would be a physical form of control, and sometimes they also use chemical control as well, especially in some of these areas that they may not be seeing a lot of relief from the giant Salvinia weevil. So the water hyacinth weevils, these were introduced in the 1970s, and they're widely distributed throughout the range of where water hyacinth is in the US. The life cycle is typically 2 to 4 months and is dependent on temperature. And so they cause feeding damage that reduces the plant's ability to regenerate, which is very important with water hyacinth. It can double in population with just 4 to 5 days. The adult weevils produce characteristic rectangular feeding scars on the leaves that you can see at the top right-hand corner photo there. And the larvae tunnel inside the leaf petioles to the crown or meristem, where they damage new growth. And so this feeding damage allows plant pathogens to come in and invade the feeding scars and larval tunnels, and therefore weakening the plant. So they're kind of offering, they're kind of giving ability for some of these pathogens to come in and take over and take care of the plant naturally. So most of the time they're not going to offer complete control. They're going to stop it from being able to reproduce, but they're also going to be weakening the plant at the same time. So hopefully something else can come in and offer further control. So moving on to our herbivorous fish, and this is where I'm going to spend the majority of the time, and that's just because with our insects, they aren't commercially available to the public. And so this is an issue I see, we have a lot of private landowners that will go out and they'll read different blogs or articles about these particular species, but to be honest, they're not available to the public, and they require very large amounts to be stocked. So for example, the alligator weed flea beetle is about 7,500 flea beetles per acre of alligator weed. And so most of the time, you're not getting that large of a density, right? And even then, it's best used as an integrated pest management strategy with some other type of control. Whereas with our herbivorous fish, you might see more control with them just by themselves as well. So here we have our Mozambique Tilapia. This is native to Africa, but it is relatively cold intolerant, as you would think, with it being an African native. It becomes lethargic when the water temperatures approach about 55 degrees Fahrenheit, and then they'll begin to die off when the water temperatures dip below 50 degrees Fahrenheit. So this is important to keep in mind wherever you are in the state. But other than their cold intolerance, they are a pretty hardy fish, and they're very tolerant of poor water quality, including low dissolved oxygen, which is something that most of our Texas ponds experience during warmer months. So with our Mozambique tilapia, all of our tilapia species are considered exotic prohibited species in Texas, and they are regulated by Texas Parks and Wildlife Department. So they cannot be imported, exported, transported, or sold without either a permit or under a regulatory exemption. They can be stocked legally in ponds following guidance from TPWD. But just keep in mind that it's unlawful for tilapia stocked in private ponds to escape anywhere. And that's with any fish. If you stock any fish, whether it is a sunfish or a bass in your pond, it is unlawful for them to escape out of your pond. So keep that in mind. It's not just with Mozambique tilapia or your grass carp. Obviously, there's bigger more things are going to happen versus if triploid grass carp gets, escapes, or a tilapia escapes versus a bass, but regardless, it's illegal. So with our Mozambique tilapia, in the past, there had been a historical lack of oversight in terms of stocking. It wasn't really being regulated. And so there was also an issue where our retailers, so our aquaculture producers and sellers, had a really hard time identifying tilapia species, specifically Mozambique tilapia. And how the law was written initially was that if it was a species other than Mozambique tilapia, then that was unlawful to sell it. And so this was putting a big pressure on our producers and our sellers. So these are two issues that they had, or TPWD was facing. And so they also took it a step further, and they're looking at potential negative impacts that it would have on species of greatest conservation need in Texas. And it saw that there was going to be potential negative impacts to 19 species or subspecies in Texas if tilapia were to escape in some of these areas that they were being stocked. So in western areas of the state, they saw that there were thermal refuges where this is where your tilapia were able to survive if they did escape into some of these rivers. And so in the past, it had been thought that since they do begin to die off when the water temperature is 50 degrees Fahrenheit, that it wasn't as much of a big deal, right? But then they were able to see that they did have these refuges in certain areas of the state that were increasing survival from year to year, which could have a significant impact on these species that we see here. And so Texas Parks and Wildlife identified 2 management zones, and this was created in a response to a spatial conservation assessment. And so they had the distribution of potentially impacted fish of species of greatest concern, and they made this a conservation priority, right? And so you can see the top photo that you see here, the red areas are where most of those species that I listed would be affected the most. And then they have a distribution of historical tilapia pond stocking. So this is the economic priority, right? And so this is just the bottom photo or map is showing where the majority of really the ponds are in Texas. If you look central to East Texas, that's where you're going to see the majority of ponds across the state, and they realize that it is important economically to have these tilapia to be sold. And so they looked at habitat degradation, and tilapia survival and pre-existing factors to come up with this map that you see here. And so this was approved in January of 2021. And so they have the conservation zone, which is in the green, which is the left side of about I-35 that you see on there. And Texas Parks and Wildlife has the whole list of counties on their website. But if you are in the conservation zone, you do need approval from Texas Parks and Wildlife to stock Mozambique Tilapia and some of their hybrids, which are now allowed as well. And so if you do get approval, this is specific to a pond. It is transferable with property sale, but it is invalidated if the pond is modified in a way that increases escape risk, because that's really what they're trying to prevent in that conservation zone. Because as you saw in the graph on the last slide, that's where most of these species of greatest concern are. So when they look at escape potential, they're going to look at, is the pond an impounded creek? Has it been modified to help prevent escape? They're going to look at flow lines, flood zone maps. They go through satellite imagery. They look at signs of overflow. And so they look at several different factors. As you can see here, they do not take the approval or denial very lightly. So when we're talking about stocking tilapia, tilapia must be stocked in the spring after the water temperature has stabilized above 65 degrees Fahrenheit. And again, this is just because of their cold intolerance. You don't want to stock them too early. So then one morning, if there's a dip in temperature over the night, you don't go out and see all of your tilapia dead in your pond. So again, it's dependent upon weather conditions. Some tilapia may survive more than 1 year, but pond owners should expect to restock annually. They can be harvested in the late fall when the water temperature is approaching some of those cooler temperatures. And I really try to push this with people who do stock tilapia, because they do cost a little bit. They're a little bit expensive, as is any fish when you're stocking your pond. And so you can harvest them just like you would with catfish or your bass. You can harvest your tilapia, put them in tacos. They can be consumed like your other species. That's why it's one of the biggest food fish in the United States and in across the world as well. Stocking rates vary depending on species and abundance. And so this is just going to be what aquatic vegetation species are present and how much of it. But generally talking, our stocking rates that we recommend are 15 to 20 pounds of mixed sex adult tilapia per acre. So the reason why we recommend adult tilapia when you're stocking them is because most of the consumption is going to be coming from their offspring. And so tilapia actually exhibit mouth brooding behavior of both eggs and larvae. And so for a lot of these species, they'll spawn about every 20 days, as long as the water temperatures are around 75 degrees Fahrenheit. And so this will allow them to fill the pond with a lot of those offspring that are going to consume most of the aquatic vegetation. And so, as you can imagine, if the females are worried about holding eggs and larvae in their mouth, they're not going to be consuming a lot. So what really the most control is coming from those offspring that she's holding once she releases them. So for that reason, since most of your control is going to be coming from your offspring, you're not going to see an effective form of biological control if there's a large predatory fish population present in the pond. And so this would be an example if you have a trophy fishery with tons of largemouth bass in there, you're not going to see a lot of control from your tilapia, because basically what that means is you just stocked a very expensive prey fish for your largemouth bass to consume. So when we're talking about diet, our Mozambique tilapia, they're most effective at controlling small floating plants that sit on top of the water surface and are typically high in protein. They're most effective at controlling duckweed and azolla species, which I saw in your email the other day. Those photos were in there, and I'll show you a couple here in a second. But they're also known to consume small amounts of water mill as well as filamentous algae. So the misconception here is, and I get mixed results about filamentous algae and tilapia, but a lot of studies show that tilapia normally only consume up to 10% of filamentous algae as part of their diet when other food sources are present. So remember that they are going to be eating a lot of other things. They're not necessarily just going to be eating what you want them to consume. And so with filamentous algae, most of the time, they're not able to consume enough to keep up with its reproduction. And so they might consume a little bit of it, but filamentous algae, you might know it as pond moss or pond scum, reproduces very readily. And so the remaining portion of their diet is going to be comprised of zooplankton, phytoplanktons or microscopic algae, detritus, small fish, including other tilapia, other vascular vegetation, insects. So they're consuming a lot more than just the filamentous algae. So here's photos of filamentous algae mats. And so again, this is referred to as pond scum or pond moss, and it's the #1 issues that we see in ponds. So when we talk about filamentous algae, there's thousands of species, but they're all generally described as being made of single cells that form very long, visible chains, threads, and filaments, and they almost resemble wet cotton or wool. And so when they're actively growing, they're actually at the bottom of the pond, attached to the sediment or any other type of substrate, almost growing like a carpet. And that's when typically your tilapia will consume some of those healthy growing cells. Whereas you see right here in these photos, these are dead or dying mats. And so they've died off. The gases from decomposition have been trapped in those filaments, and now they're sitting at the top of the water surface, and that's what creates those bubbly surface mats. So here's some up close photos. We actually have Spirogyra, which is also known as silk algae, over on the left. That's included in our filamentous algae group. And then we have some other species as well. But as you can see, it can be a really big issue. And so Mozambique tilapia can be used with other control methods to help so this issue hopefully doesn't get to this point, like you see here on the right next year. Maybe they're going to go in and use some type of mechanical and or chemical control, and then they'll stock with Mozambique tilapia, and then the Mozambique tilapia will help so it doesn't come back as quickly. Here's a picture of Azolla, also known as mosquito fern. We have 2 different species of Azolla in the US, but you're going to see Carolina, Azolla Carolina, more throughout Texas. And so very small, right? And so then some of the issues that we have when we're talking about ID, because of course you want to be able to identify what you have to select a effective management option. We have Azolla over here on the right, but we actually have something else over here on the left. And I wish I was with you guys in the classroom, because maybe a couple of you would know what this is. Very characteristic, and I've actually been seeing more and more cases of this in the past month or 2. But here's the difference. So we have our Azolla again over on the right, very small, almost looks feathery, many overlapping leaves, completely free floating. Over on the left is actually Iglena. So this contains more than 1,000 species in that genus, and they're single cell flagellated microorganisms that have both plant and animal-like characteristics. And these are not going to be readily consumed by your Mozambique tilapia, and these actually can produce toxins for other fish and irritations for mammals. And so we would hopefully want to treat it with another method, possibly immediately if possible. So some of the other species that our tilapia like to consume are our duckweeds. So we have 5 common species here in Texas. If anybody has seen our duckweed identification and management publication, you might be able to point out some of these, but just to go over them quickly, on the bottom left, we have our dotted duckweed. And so this is actually a non-native invasive species. It's listed on Texas on TPD's prohibited list. So just a quick little trick, dotted duckweed does not actually have this pigmented dot like you see on the top right. The top right is actually giant duckweed, which is not on the prohibited list, but dotted duckweed is called dotted duckweed because it has these little bumps that you see on the top of these leaves or frogs or whatever you want to call them. But with our duckweed species, you'll know it's a duckweed species by several different characteristics, mostly their size. And the second most importantly is that they have 1 or more root nerves, depending on what species you're looking at. But they'll always have 1 at least, no matter what species. Because we have some other issues with identification when we start looking at, if Mozambique tilapia are going to control this. And so a lot of people will go up to a pond like this and they'll think it's either algae, or sometimes they'll think it's duckweed as well. This is actually watermill. So watermill is the world's smallest flowering plant. And Mozambique tilapia will consume it. But for the most part, since it's so small, it's really hard for them to consume. And so they will only consume it if it's part of a byproduct. So if it's mixed in with duckweed species, which they really like, and it's high in protein, they will consume some duckweed then. But if your pond looks like this, in this past photo, and over on the right was actually watermill, over on the left is algae. But if you're seeing an issue like that, your tilapia, for the most part, aren't really going to take care of it to the extent that you probably want them to. Just some more ID issues. So again, no matter what species of duckweed, it has at least 1 root nerve, whereas watermill does not have any roots. Watermill is about the size of a grain of salt, and there can be 5 to 10 billion individual plants per acre. So very small. Duckweed is a little bit larger, but still relatively small, as you can see here in this photo. And that's really what Mozambique tilapia like to consume. You might also get duckweed confused with our Salvinia species. And so this is one where you would be looking for those characteristic leaf hairs of Salvinia, right? So you can see the leaf hairs with the naked eye, and that's one of the biggest ways to tell them apart from duckweed, especially if you're not familiar with the size, if this isn't something you see every day. And this isn't an identification lecture, but I just wanted to put this in here to show you guys that there are common identification mistakes that can cause people to think that some of these biological control methods don't work, because Mozambique tilapia will not consume Salvinia species, or it's not a preference of theirs. So here they are up close. And again, it may seem really obvious just due to size, but if you haven't seen it before, it's very easy to mix up a lot of these very small green floating plants. So moving on to our triploid grass carp. These are also known as white amur, which are native to the rivers that flow through Western Asia. The fish are from natural populations in the wild are diploid, which means they will reproduce in flowing waters under ideal conditions. They have those 2 sets of chromosomes. But in order to create triploid grass carp, we've had to take fertilized eggs of diploid grass carp and subject them to temperature or pressure shock, making the grass carp triploid. And so this extra set of chromosomes makes the triploid grass carp sterile and ensures that if fish do not escape, or that if fish do escape into non-impounded waters, they will not be able to reproduce. So in Texas, only sterile triploid grass carp are allowed to be stocked after receiving approval and a permit from TPWD. And all grass carp sold within the state are tested by U.S. Fish and Wildlife Service to ensure that they are triploid and can only be served or sold by certified vendors. So there's multiple safe holds in place to ensure that even if they do escape, there's less impacts. So up to 10 grass carp per acre can be approved within a 1-year period. And if approved, all new permit holders will have up to 36 months to stock fish. And this is something that is recent. Within the last year, they've moved this allowance up to 36 months. And so since grass carp are known to seek out some of these flowing waters, in order to get a TPWD permit, it requires that there must be a fish barrier installed on spillways and overflow pipes to limit these grass carp escapes. Because again, any escapement of any fish you stock into your pond is illegal. And here's just some diagrams that Texas Parks and Wildlife have on their website to help you set up an escapement and barrier. And so our grass carp are typically stocked in early spring after many of the aquatic plants have died back from winter temperatures so they can consume new growth. So if you stock before the water temperatures reach 75 degrees Fahrenheit, this can decrease stress effects from handling during transport. And this is really with any fish stocking that you're going to deal with. You don't want to be stocking fish in a Texas summer in July or August, trust me. If large populations of the aquatic vegetation are already present, so say we have a really large population of a submerged species like southern naiad. If we go ahead and stock grass carp in, we might not see results very quickly, or you might not even see results until the following year because they're not going to be able to keep up with that reproductive rate of already established plants. And so you might have to combine them with other control options. So maybe a herbicide treatment or a water drawdown to potentially achieve those results more quickly and reduce the number of fish needed to be stocked. Large aquatic vegetation infestations should be managed prior to stocking if your dissolved oxygen concentrations are not acceptable for fish survival. So this is really going to be an issue if you are stocking when your water temperatures are really above 75 degrees Fahrenheit, or if you already have a lot of aquatic vegetation in the pond, because every time you have aquatic vegetation, it's producing oxygen during the day, right? But at night, it is respiring, so it is consuming oxygen. And most of our submerged species that are in the water column are consuming more oxygen than they're producing during the day. So this is why we see a lot of low dissolved oxygen fish kills in the summer. And especially with some of our larger fish, they're the first ones to go. And so grass carp would be pretty susceptible to low dissolved oxygen conditions. So there's no real stocking rate or silver bullet, just as with anything aquatic vegetation related, but you can't really apply everything or a general recommendation to every situation. And you might take more than 1 year to start seeing results. And so because grass carp are so difficult to catch and remove once stocked, it's recommended to use more of a conservative approach when stocking. And so you can go ahead and stock lower densities initially, so maybe 5 to 7 per acre, and then you can always evaluate it within a year or a year and a half, because you can add more fish as long as you're within that 36-month period of that maximum approval number that you get from TPWD. So again, if you get a maximum of 10 fish that you can stock, if you go ahead and stock maybe 5 fish per acre, you can evaluate it for a year and a half. You go and look and you say, okay, they're not really consuming a lot. We just have a lot of vegetation that's growing, which usually means that you need to do something else with your pond as well, some type of nutrient remediation. But anyway, and so you would go back and you could go ahead and get the other 5 and stock them in the pond as long as you're within that 36-month period. When you stock grass carp, they should be 10 to 12 inches long, just when you're stocking them to reduce losses due to either escapement, which again is illegal through those outflows, or from predation from your catfish and your bass if they are present in the pond. And so again, if you look at literature, you'll see anywhere from 2 to 50 grass carp have been used per acre in many cases in ponds, reservoirs, really been dependent on the area, the type of species there are, how much, but generally speaking, 7 to 15 grass carp per acre is kind of the general range. Again, you can only get a maximum of up to 10 from TPWD, but if you do get that maximum of 10, and if they're still not cutting it, and if there's species in the pond that they do prefer, they're just not keeping up with it, you can go back and reapply and ask to get more put in your pond as well. So this is basically what I just said. Your consumption rates can be influenced by age and gender of the individual fish, and then also site-specific factors such as species abundance, diversity, placement in the water column. And so other things to keep in mind, the feeding activity of grass carp begins to slow down when your water temperatures decrease. And eventually they'll stop feeding altogether, usually when the water temperature is below 37 degrees Fahrenheit. So there is a time when they're inactive. And then they'll start ramping their feeding back up when, as the water temperatures warm to about 68 degrees Fahrenheit. So depending on the amount of aquatic vegetation in the species, they can consume about 40 to 300% of their body weight per day. And so they grow very rapidly. They consume a lot, and they can be very noticeably effective biocontrol in your pond. They can grow to more than 60 pounds and live longer than 10 years, but eventually their feeding decreases over time. And so for that reason, you may need to be restocking them every 5 to 7 years if some of the vegetation is still present. Some of the vegetation that they prefer, if it's still present and you see that maybe it's coming back a little bit stronger than it has in the past 5 or so years, then it might be time to reapply and restock. And so you're basically just going to be having giant dinosaurs swimming around in your pond, but they're not out competing with your other fish species. They're kind of just hanging out in your pond. Again, like I mentioned, they're pretty hard to be able to remove. And so most of the time people just leave them. If they do have a low dissolved oxygen dip in, July or August, most of the time that's when their older grass carp are going to die off. So our grass carp are most effective at controlling some of these tender submerged species that are in the water column and a few small species of floating vegetation. But for the most part, they favor really soft vegetation with limp stems that are submerged in the water column, and they do not offer control for our emergent or shoreline vegetation because they can't reach it. It's usually tough, fibrous, woody. It usually has a very thick cuticle, so they're usually waxy species. And they offer little to no control of filamentous algae or phytoplankton. All of our submerged species that have hard stems, stiff leaves, or spiky projections are also not preferred. So even if it's in the water column, it doesn't necessarily mean that it's going to control it. And so this is going to be like our coontails and water milfoils. Coontail is also known as hornwort because it does have horn-like projections, and water milfoils are generally pretty stiff. There has been some cases, though, where they have offered good control, and you'll see mixed results about coontail, but that's typically because they've already eaten all of the other vegetation that they want to consume in the pond, and they need to consume something, right? So if they're starving, obviously they might eat something like coontail with a stiffer stem or some of those horn-like projections. So here's just some examples of what grass carp will consume. They really love hydrilla. They love similar species like Egeria, Elodia as well. You can see very soft stems, very soft leaves, very easy for them to consume. It's one of the reasons why triploid grass carp have been stocked in some of these large reservoirs for hydrilla management. And then we have our southern naiad. So southern naiad is a native species. This is something that can be beneficial depending on what you're using your water for. But some people also see this as a nuisance, and triploid grass carp love southern naiad. It's very soft. As you can see, the leaves are very thin. It's something that they're rated as excellent in terms of control. We also have our native pondweed species. Again, these are species that can be a benefit. So keep in mind that your grass carp aren't just going to control the invasive non-native thing in your pond just because you know that it's not supposed to be there, but they will control some of your native vegetation as well. Not only your naiads, but like your pondweed species as well. But these can become an issue in some ponds, especially very shallow ponds. And so sometimes people, depending on their water use, again, may not or may seek control. And grass carp are excellent at controlling our native pondweed species. Okay. And with that, I will take any questions. I know it was kind of a lot of information there, but I did send the 2 fact sheets that we put out this year on Mozambique Tilapia and triploid grass carp. And then we have a lot of other resources at the Aquaplant website. And so if you're not familiar with the Aquaplant website, I will go ahead and show you here. So again, it's just aquaplant.tamu.edu. And what most of my landowners use it for is they go in and they click identify a plant. They try to figure out, okay, which of the 4 classifications does it belong to? They hit submerged plants if they think it's in submerged. And then they go to something like the Southern Naiad page where they can scroll through photos. They can look at characteristics, but then they can also hit how to manage this plant. And it has all of the effective management options in those categories we talked about listed on there. If you go back to home, we have an area where it has aquatic vegetation fact sheets. And this is where we have some of our fact sheets like the identification and control of duckweed and watermill. So if you're interested in maybe not even managing duckweed and watermill, but you just want to have some quick ID references, you can go and look at that, and they're completely free to download. Okay, I'm seeing some questions. Chat. Just.
Can you hear me?
Okay. Yes.
Let me get to the chat side.
Okay, so Janice asked in the chat, Azolla, other than treat immediately, what kind of treatment is recommended as first and second choice treatments? Okay, so for Azolla, when I said treat immediately, I meant that was directed at the Iglena, which is the flagellated microorganism. That's something that you really need to treat immediately just because it can be dangerous to livestock. and then and your fish as well. But in terms of my first and second choice treatments, if someone is able to get approval for Mozambique Tilapia, I highly recommend that they go that route and they look into that, because the Zola is very small. So it's very hard to use a lot of other control methods like mechanical control methods or physical. It's going to be hard to get all of those small plant material out, and it reproduces every couple of days, so it can double its population pretty easily. If they're not able to get approval for tilapia, then I recommend chemical control, and that's usually diquat, which is a contact herbicide. Any other questions?
Curious why the state governments continue to want to introduce exotics to control things. I know in the past, every time they do it, it doesn't seem to ever end well. Just curious.
Yeah, that's a good question. I don't think that's one I could really answer. It's something that has been used. These herbivorous fish have been used for many years, and I think now we're finally just getting into I think of control kind of like a pendulum, right? And so we're always it's always swinging, and I think we're finally getting to the point where with some of these changes, especially with Mozambique Tilapia, they realize that there is a need to have these a little bit more regulated. Obviously that might have been a after the fact thought, but at least we're moving in the right direction, and they're looking at, you know, what some of these escapes could impact for some of these species of greatest concern. So yeah, all I can say is I think they're moving in the right direction. And I will say with some of our insects, if that's one of the things we're learning about right now in one of my classes is most of these biological control insects are very specific to these invasive plant species. They really don't have a lot of non-target impacts. They're really only going to be targeting that specific species. So when we're talking about some of these like thrips and these flea beetles, very specific to the plant that they're going to manage. But yeah, traditionally herbivorous fish are more non-selective.
Okay, we got another question.
What tilapia is it that's in Lake Onastet?
What was the question? Sorry.
What tilapia is in Lake Onastet?
I'm not sure.
Okay. Any more questions? Okay, we got one. Hold on.
Water drawdown, also known as the drought, has taken care of my aquatic vegetation problem in my creek. We couldn't qualify to get the carp because of the overflow problem. Is there anything I should be doing to my dry creek bed right now to prevent the vegetation from coming back?
Okay, so I think I heard that a little bit. So you're managing a creek bed that is dried out, and you can't get carp because it's not an impoundment. It's not a private impoundment. You can't prevent escapement, and you're trying to re-establish vegetation. Is that what you said?
No, trying to keep it from coming back. It fills up our swimming hole.
And it runs into a creek?
It is a creek that has a small dam, a spillway. And so it flows on down probably to the Medina. So
Okay.
I'm just wondering if there's something I could be doing now to prevent it from coming back.
So that's going to be difficult. And I'm sorry, I mainly deal with impoundments that are not draining into any creek ways. That's going to be Texas Parks and Wildlife. And so anything that you do in your impoundment, if it can potentially harm people downstream, or not harm people, but impact downstream landowners or downstream creek beds, then I can't really make any recommendations, if that makes sense. If you talk to Texas Parks and Wildlife, they may be able to offer you some guidance for that, but I don't want to make any recommendations for any public water bodies. That's beyond my area. I'm sorry.
Okay, thank you. Anybody have any more questions? No more, Lonnie? So Brittany, thank you. That was a great presentation. Appreciate that. And with that being said, hope you have a great week, and this AT is over. Thanks, Brittany.
Awesome. Thank you. Have a good night.